So this will be for domain and range. Okay, let's say you have a set of x, y coordinates, and you can see the x coordinates are the first numbers, and the y coordinates are the second numbers or letters. All right, so this is our xy coordinates, and the domain is going to be the x coordinates. So that's going to be 1, 2, 3, and 4. And then the range is going to be the y coordinates, which are just a and b. Okay, so even though a repeats and b repeats, the range is just a and b. So for the functions in this book, the domain will consist of the real numbers we are allowed to use for x, and then the range will be all of the y values. All right, let's look at some examples. We want to find the domain. Those are the possible x values. So in this function here, in the numerator, there's nothing that x can't be. Okay, so we're okay in the numerator, but we know the denominator cannot equal 0. So if we set the denominator x plus 3 equal to 0, and you do minus 3 on both sides, you have x equals negative 3. So that is the one number that x cannot be. So basically, if you were on a number line, and you don't have to use the number line every time, but if you were on a number line, you would have x equals negative 3, and it wouldn't include negative 3, but it would include everything to the right and everything to the left as well. It could be everything except negative 3. So how do we write that in interval notation? Well, we start from the left at negative infinity, and we're going to finish on the right at positive infinity. All right, so remember, for infinity or negative infinity, you use the curved parenthesis, and this runs from negative infinity all the way to negative 3. Now, it does not include negative 3, so we use the curved parenthesis, and that is in union with, and again, we go from negative 3 to positive infinity. Okay, use the curved parenthesis because you don't include negative 3, and that goes to positive infinity. Use the curved parenthesis for infinity. So that's your answer right there. That's the range, the domain for the x values. All right, please pause and try this one here. I'll give you a hint. This denominator, you want to take this denominator and factor. Use factor by grouping. Set it equal to 0 and see which numbers you get. Those are the numbers that x cannot be. All right, so let's group this. We have x to the third plus 2x squared. And I'm going to use parentheses. And then negative x minus 2. And use parentheses. Recall, when you enclose a negative sign inside parentheses like so, you want to put a plus sign in the middle. All right, and let's see. Lowest exponent is the 2, so we're going to factor out an x squared. X to the third divided by x squared is x. 2x squared divided by x squared is positive 2. Over here, we want positive x. Here we have negative x, so I'm going to factor out a negative 1. Negative x divided by negative 1 is x. Negative 2 divided by negative 1 is positive 2. Okay, and you can see now we have a common binomial in x plus 2. And we also have x squared minus 1. And we want to find the zeros, so set it equal to 0 because the denominator cannot be 0. All right, so anything times 0 is 0, so we can set each one equal to 0. All right, so we have x plus 2 equal to 0. And we have x squared minus 1 equal to 0. Over here, minus 2 on both sides, and we have x equals negative 2. Over here, plus 1 on both sides, we have x squared equals 1. And taking the square root of both sides, the square root of 1 is just 1, but when you do square root on both sides, you need the plus and the minus. So x equals plus or minus 1. So these are the values that x cannot be. So if you did this on the number line, we would have negative 2 and plus or minus 1. So negative 2, negative 1, and positive 1. Okay, and it equals everything except those values. Everything except those values. So shade to the right in between, and we shade to the left. So we actually have 1, 2, 3, 4 intervals for this. All right, so down here on the left is your negative infinity, and over here on the right is your positive infinity. So this runs from negative infinity up to negative 2 in union with negative 2 to negative 1. And that is in union with negative 1 to positive 1. And finally, in union with 1 to infinity. And that's it. 4 intervals. All right, please pause and think about this one for a minute. See if there's anything that would make the denominator equal to 0. Okay, so if you think about it, this will never be 0 with x being a real number. Okay, if you set the denominator x squared plus 1 equal to 0, and you subtract 1 from both sides, you'll have x squared equals negative 1. Okay, and if you took the square root of both sides, you'd have the square root of a negative number. And that would go into imaginary numbers. So basically, x can be anything because the denominator will never equal 0 no matter what you plug in for x. So basically, we say x is all real numbers, but there's a way to write that. All right, on the interval, basically, x runs from negative infinity to positive infinity. That would be the answer. Because no matter what you put in for x, it will work. It will be a legitimate part of the domain. All right, so let's look at this example here. They want us to find the domain. Now, if we're sticking with real numbers, we know we can't take the square root of a negative. Okay, so the part here that's under the square root, the x minus 8, has to be greater than or equal to 0. All right, x minus 8 is greater than or equal to 0. You can take the square root of 0, but if you take the square root of a negative, those are imaginary numbers. All right, so if we just do plus 8 on both sides, 8 minus 8 cancels, and x is going to be greater than or equal to 8. So let's see, on the number line, we have 8, and it can equal 8. All right, it can equal 8, and it's going to be everything greater than 8. So that's it. And if you want to do the interval notation, you have the 8. This is positive infinity over here. You start at 8. You use the square bracket. because it includes 8, and then it runs all the way to positive infinity. You use the curve bracket for infinity. So that's it. All right, please pause and try this one here. And remember, you want to set this greater than or equal to 0. Okay, so you're going to have to factor this and find the parts that are greater than or equal to 0. Basically, you have to find the zeros and then plug in the values in between. All right, so we have x squared minus x minus 2. And basically, x squared minus x minus 2 has to be greater than or equal to 0. All right, we need to factor this. Pretty easy. Two numbers that multiply to -2 and add to -1, right? So if we wrote out the factors for -2, we have -2 times 1. That would add to -1. So this is going to equal x minus 2 times x plus 1. And we want greater than or equal to 0. I'm going to set it equal to 0 for now. Okay, because I want to find the zeros. Either one of these can equal 0. So x minus 2 equals 0. And also x plus 1 equals 0. Over here, plus 2 on both sides gives us x equals 2. And over here, minus 1 on both sides gives us x equals -1. All right, so let's do the number line and plug in the numbers in between. All right, we have -1 and we have +2. So it is not going to equal those values. Actually, it is, because it could equal 0. But at any rate, we're plugging in the numbers in between. All right, so on the left, let's try x equals -2. All right, so if we take this and use x equals -2. -2 minus 2 is negative. -2 plus 1 is negative, so that's a positive. Right here. In between -1 and 2, we're going to do x equals 0. All right, so let's plug in x equals 0. Let's see. 0 minus 2 is negative. 0 plus 1 is positive. Negative times positive is negative. So that's for this section, the 0 section. Greater than 2, let's try x equals 3. All right. So if you plug in 3, that's positive. You plug in 3, that's positive. So at x equals 3, we have positive times positive. And that's a positive. All right, so we're in business. We want everything that is greater than or equal to 0. So we only want the positive part. So if we had a number line here, we would start at -1, and do everything to the left. And we would start at 2 and do everything to the right. So that's it. We want the positive section because it's greater than or equal to 0. In interval notation, on the left end is -infinity, and on the right end is positive infinity. So we run from -infinity, curve parenthesis, to -1. It includes -1, so use the bracket. In union with 2, It includes 2, so use the bracket, and that runs to positive infinity. So that's it. All right, they want us to find the domain here. We see this is a 4th root rather than a square root. But just like for the square root, when the root is an even number, the part underneath the radical has to be greater than or equal to 0. So if it's an even root, it has to be greater than or equal to 0. Okay? If it were an odd root, that's fine. You can, if it was like the cube root, the 3rd root, you can take the 3rd root of a negative. But for the even root, it has to be greater than or equal to 0. So right here, x squared plus 5 is greater than or equal to 0. And if we did minus 5 on both sides, we'd have x squared greater than or equal to negative 5. No matter what you plug in for x, it will always be greater than or equal to negative 5. So it's basically all real numbers. All right, and when it's all real numbers, the domain runs from negative infinity to positive infinity. That's all real numbers. Okay, here's another example, but here we have a cube root. Okay, it's the 3rd root, and you can take the cube root of a negative. So right here, this is also going to be all real numbers. All right, it's not this is always greater than 0, but it's that you can take the cube root of a negative. So this runs from negative infinity to positive infinity. All right, just as an example, if you had the cube root of negative 8, like let's say you plugged in x equals negative 15, and you had the cube root of negative 8, that is asking what multiplied 3 times would give you negative 8. All right, and if you had negative 2 times negative 2 times negative 2 and took the cube root of that, you'd have negative 2. So you can plug in a negative if the root is an odd number. All right, so for this type of problem here, there's no radical symbol, there's no square root, and there's no denominator. So in this case, we would just say all real numbers. All right, there's nothing that x can't be in this function here. All right, for this one right here, pretty simple. The numerator is as is. The denominator cannot be 0, okay, because you can't divide by 0, and under the square root has to be greater than or equal to 0. So we could say 4 minus x is greater than or equal to 0 because of the square root. However, the denominator can't be 0, so we have to remove that equals part. All right, so it's not going to be equal 0, it's just going to be greater than 0. All right, and if we do plus x on both sides, we'll have 4 is greater than x, or x is less than 4. That's the only restriction. So on a number line, if you were at 4, and you would not include 4, and it's everything less than 4. So this is negative infinity over here, and it runs from negative infinity to 4, but it doesn't include 4, so that would be it. Okay, here's an interesting problem, because this denominator cannot equal 0, and this radical has to be greater than or equal to 0. So it's almost like 2 problems in one. All right, First, let's see where the denominator equals 0, because that can't be the case. All right, so we're going to factor this and set it equal to 0. We need two numbers that multiply to -4 and add to 3. Okay, if we write out the factors of -4, we have 4 and -1. Those two add to 3. So x plus 4 and x minus 1, that is equivalent to what we have in the denominator. All right, and if we set that equal to 0, x equals -4, and x equals +1. All right, either of those would make that equal to 0. So x cannot be either of those numbers. Now for the x plus 10, it's under the radical. That has to be greater than or equal to 0. All right, and if you do -10 on both sides, you have x is greater than or equal to -10. So on a number line, we have -4 and 1. And it cannot equal those numbers, so we'll do the open circle here. It cannot equal -4 and 1. And it can equal -10, but it has to be everything greater than or equal to that. So we put a solid dot here, and we're doing everything that's greater than -10. But you can't include -4 and +1. All right, so this just goes to positive infinity. All right, so -10 is okay. If we were to write the interval here, -10 is okay, so we want the square bracket on the -10. And that runs to -4 with the rounded parenthesis. And that is in union with -4 to +1. And that's in union with 1 to infinity. All right, so that's it right there. 3 intervals.